Now let's understand state vector and policy. Okay, so basically I mean, think of state vector, like a list of features. So basically it's a variable that captures relevant information about the environment. Okay, so the state vector can be thought of a snapshot of environment that encapsulates all the necessary information required for the agent to choose the its next action. So it is important to note that the state vector is problem specific and varies depending on uh, task at hand, so it can be different for different thing. Okay, so therefore it is crucial to design an appropriate state vector that captures the relevant feature of the environment and provides the necessary information for the agent to make optimal decision, not the irrelevant features. So yeah, that is what state basically represents. So um, uh, so to understand it in a different way, so it represents the current situation of the agent within the environment. Okay, so for example, in a game of chess, the state would be the position of all pieces on the board, and the turn of each player and the number of moves made so far. Okay, however, not all these variable may be relevant to agent decision making, but somewhat. So the agent next move depend only on the current board configuration. Okay, because obviously you make decision where currently my piece of player basically is, right? So the agent next move or obviously depend on the current board configuration. That is what I said. So the player turn and the number of move made so far. Okay, so obviously I mean, suppose you one side is AI, one side is player. Now based on what player is you know playing with, I mean any piece of uh, board configuration, and based on that configuration we will be making decision, our AI will making the decision. Okay, so therefore the state in this case would be the combination of three variable, and the agent could take decision based on this relevant feature, which is uh, you know uh, number of move made so far, uh, I mean for which player the turn is right now, and what is the position of all the boards. So these type of feature will be relevant for our agent to make any decision. So AI thought consider state vector is a list of features that help agent to take an action. Okay, so you will see like I mean we store all the relevant information in a list, like that is Python data structure. So that is what state vector is. Now the next is policy. Okay, now to understand policy, uh, uh, so basically policy is like a mapping between state and environment, which help us, I mean that action to be taken from those state. Okay, and the policy can be either deterministic or stochastic. So let's understand both of them. So a deterministic policy map each state in a single action. Okay, each state in a single action, and while the stochastic policy map each state to a probability distribution over action. So what I mean by that, let's understand in other words. So the stochastic policy specifies the probability of taking each possible action in that given state. Okay, now like we know, the RL agent goal is to learn an optimal policy that maximize the expected cumulative reward over time. This can be achieved through trial and error learning, right? And where the agent explore the environment by taking different actions, observe the resulting state and the reward, and update its policy accordingly. So there obviously there are various methods for learning a policy in reinforcement learning, like we discussed in previous videos also, such as value based, policy based, and actor critic based methods. So in value based method, the agent learn optimal policy by estimating the value for each state, or you can say state action pair. In policy based, the agent directly learn the optimal policy by updating its policy parameter. And in the actor critic method, the agent learn both policy and the value function, which is used to guide the agent action in the environment. So we'll deep dive in these thoughts later on, because I will be making separate video for each of this value function and I mean actor critic, policy methods, all those things. Okay, for now let's just focus on this deterministic policy and probabilistic policy. This is also called stochastic. Okay, so now in deterministic policy, basically this policy map each state to a single action. So to understand this, in other word, so for a given state, the policy specifies exactly which action the agent should take. Okay, so the example would be like a deterministic policy for a game of chess might specify that in a certain board position, the agent should always move its bishop to a certain square, you can say that. Okay, or you can say in other hand, the stochastic policy map each state to a probability distribution over action. So in other words, for a given state, the policy specify like probability for taking each possible action. Now if you have the probability, obviously for those action which have maximum probability, you will get that or you will take that, right? So for example, stochastic policy for a game poker, okay, might specify that certain situation the agents would raise with the probability of 0.7 and fold with a probability of 0.3. so now you have a confirmation, right? You have a 70% of probability that you should raise with it, and if you want to fold, you can fold it with 0.3% of probability, for an example. Now there is an advantage of using probabilistic, or you can say stochastic policy. Why? Because stochastic policy is that it allow the agent to explore different action and learn from resulting reward. For example, the agent only use if it use deterministic policy, it might get stuck in a suboptimal policy. Okay, if it always chooses the same action in a certain state. So that is what disadvantage of deterministic policy over stochastic policy. Now let's say you are using stochastic policy. Now the agent can explore different action and learn from different resulting rewards. So this may be take longer iteration to learn, but it may take lesser iteration. So however, the disadvantage of stochastic policy is that it come to be more difficult to optimize than deterministic policy. So basically in a stochastic policy, the agent must learn to balance exploration and exploitation, which we will be learning in next tutorial also, but it must balance this exploration and exploitation part, which can be a challenging problem in itself. So in contrast, a deterministic policy can be optimized directly using techniques such as gradient descent. Okay, so this is what different type of policy and state vector is. Now we'll learn what is exploration and exploitation. Okay.